Somewhere past the orbit of Jupiter, moving at a speed no human spacecraft could ever match, an object built by no one on Earth is leaving our solar system forever. It arrived uninvited, it was tracked by 20 different instruments on land and in space, and in the final weeks before it vanished into the dark between the stars, NASA released something that even its own scientists did not fully expect. Not a monster, not a signal. Something stranger than that, a set of images and readings that raised more questions than they answered, and left some of the most respected astronomers on the planet publicly disagreeing with each other about what they were actually looking at. This is the story of 3I Atlas, only the third object ever confirmed to have come from outside our solar system, and the story of what happened when humanity finally got a close enough look to see that some of what we thought we knew about interstellar visitors may not hold up. It began on the 1st of July in a quiet corner of northern Chile, where a NASA-funded early warning telescope called Atlas scans the sky every night, hunting for the kind of object that keeps planetary defense scientists awake, an asteroid or comet on a collision path with Earth. That night, it flagged something odd, a faint point of light moving in a way that didn't match anything already cataloged in the solar system. Astronomers pulled the archives, checking older survey data to see if the object had been missed before. It had. Fainter traces stretched back to the middle of June, quietly crossing the sky for weeks before anyone noticed. Within days, the orbit was calculated, and the number that came back stopped astronomers cold. The object's trajectory was hyperbolic, meaning it wasn't looping around the sun the way every planet, moon, asteroid, and comet born in our solar system does. It was moving too fast on a path too straight to have ever belonged here. It had fallen in from somewhere else entirely, sailed through our solar system on a single uninterrupted pass, and it was already on its way back out. Only twice before in recorded history had astronomers confirmed an object doing this. First in 2017 with the strange, elongated one-eye Oumuamua, whose tumbling, cigar-like shape and unexplained acceleration triggered years of speculation before it slipped away too fast for any spacecraft to follow, and again in 2019 with the Comet 2I Borisov, a more conventional icy wanderer that at least behaved the way scientists expected. This was the third. It was named 3I Atlas, the I standing for interstellar, the 3 marking its place in a very short, very exclusive list of confirmed visitors from beyond our sun. Two things separated this third visitor from the two before it, and both of them mattered enormously. The first was timing. Oumuamua had already been leaving the solar system by the time anyone spotted it, giving astronomers only weeks of usable data before it faded past the reach of every telescope on Earth. 3I, Atlas, by contrast, was caught early, while it was still falling inward, months before its closest approach to the sun. That gave NASA something it had never had before with an interstellar object: lead time. Enough lead time to plan, to redirect spacecraft already in flight, to point instruments built for entirely different missions at a target nobody had budgeted for. The second difference was reach. In 2017, humanity's fleet of active planetary spacecraft was a fraction of what it is now. By the time 3I Atlas arrived, NASA had rovers on Mars, orbiters around Mars, a probe cruising toward Jupiter's moons, another en route to the Trojan asteroids, a spacecraft threading toward a metal-rich asteroid, and solar observatories watching the sun around the clock. Almost by accident, humanity had built exactly the kind of solar system-wide surveillance network that this moment required. And almost immediately, the question started. The first strange detail was its age. Using the object's velocity and the direction it came from, researchers traced its probable origin to the thick disk of the Milky Way, a region of ancient stars that formed billions of years before our own sun existed. Some early estimates suggested the object itself could be more than 7 billion years old. Older than the solar system we live in, older than Earth, older than the sun. If that estimate holds, then 3I Atlas is not just a visitor. It is a fragment of a world that existed before our world did, a wanderer that has been drifting through the galaxy since before our planet had formed an atmosphere. The second strange detail was its size, and this is where the real disagreement began. When NASA turned the Hubble Space Telescope toward the comet on the 21st of July, astronomers led by veteran planetary scientist David Jewett expected the usual result: a small, icy nucleus surrounded by a faint halo of dust. What they got instead was a teardrop-shaped cocoon of material streaming off a solid core they could not directly measure. Hubble's imaging was sharp enough to rule out a nucleus larger than roughly 5 miles across, but not sharp enough to tell them how much smaller than that it actually was. If it had a big nucleus, there would be a blip in the middle of the image, Jewett explained afterward. And there wasn't one. The absence of that blip was frustrating in a very specific way. It meant the object was hiding its true size behind its own activity, wrapping itself in enough dust and gas to blur out the one number scientists most wanted to know. By August, NASA's infrared observatory SphereX had captured nearly a week of continuous data on the comet, and the chemical picture that came back only deepened the mystery. The instrument detected carbon dioxide gas pouring off the object in unusually high concentrations, along with water ice locked inside the nucleus and a mix of organic molecules drifting through its expanding coma. This was not the chemical signature of a young, freshly formed body. It was the signature of something that had spent an extraordinarily long time in the deep cold of interstellar space. Its ice is barely touched until sunlight finally reached it for the first time in billions of years. What made the carbon dioxide reading particularly interesting was the ratio. In comets, born inside our own solar system, the balance between carbon dioxide and water ice tends to fall within a fairly predictable range, shaped by how close to the sun those objects originally formed. 3I Atlas didn't quite fit that range. Its proportions hinted at formation conditions colder or chemically different than anything typically seen among homegrown comets, a small but telling clue that this object had condensed out of the leftover material of a completely different star under different pressures, different temperatures, different starting ingredients entirely. Scientists studying the readings were careful not to overreach, but the implication sat there quietly in the data anyway. Somewhere out among the stars we can see at night, other solar systems are cooking up comets from a slightly different recipe than our own. Then, in October, the object made its closest approach to Mars, passing within 19 million miles of the red planet, close enough for 3 separate NASA spacecraft already stationed there to turn their instruments toward it. The Mars Reconnaissance Orbiter's HiRISE camera, one of the sharpest imaging systems ever sent to another planet, caught the comet from just 18 million miles away, producing the highest resolution image of 3I Atlas captured up to that point. Around the same time, NASA's Perseverance rover, in the middle of exploring the rim of Jezero crater, briefly paused its ground operations to point its Mastcam-Z instrument at the sky and photograph a faint, moving smudge of light that scientists insisted cautiously was a comet that had been born around a completely different star. The MAVEN spacecraft, meanwhile, used its ultraviolet instrument to capture something almost impossible to picture without help. A glowing halo of hydrogen atoms surrounding the comet's nucleus, atoms being torn loose from water molecules as the ices boiled off under sunlight for what may have been the first time in the object's existence. In the images, that halo of hydrogen appears as a soft, expanding cloud stretching for hundreds of thousands of miles in every direction, dwarfing the tiny, unseen core producing it. In the same set of observations, MAVEN's instrument also picked up hydrogen signals from 2 other sources in the same frame, Mars's own thin atmosphere glowing nearby and background hydrogen drifting through the solar wind, meaning scientists had to carefully separate 3 overlapping glows in a single image, just to isolate the comet's own contribution. It was delicate, painstaking work, done under a tight window because 3I Atlas would only be this close to a spacecraft equipped to see it for a matter of days. None of these observations came easily. Every one of them required a spacecraft built for an entirely different job: surveying Martian geology, protecting Earth from solar storms, hunting for planets around other stars. To be temporarily repointed, its schedule rearranged, its handlers coordinating across time zones and agencies to make sure the narrow window when 3I Atlas crossed their field of view wasn't wasted. Mission planners, who normally spend years mapping out a spacecraft's observation calendar, had to make room, on short notice, for a visitor that gave them only weeks of warning and would never pass this way again. And then the comet did something that made even seasoned observers pause. Around the time it passed behind the sun in the autumn, invisible to ground telescopes for weeks, its outgassing intensified in a way that briefly complicated its trajectory. Astronomers detected small but measurable non-gravitational forces acting on the comet's path. Tiny nudges caused not by gravity, but by jets of gas and dust escaping unevenly from its surface, like a leaking valve, pushing the object slightly off its expected course. This is not unheard of in comets from our own solar system, but the scale and timing of it here forced scientists to keep recalculating the object's exact trajectory throughout its passage, refining the numbers again and again as new data came in. At the same time, amateur astronomers scattered across the globe began capturing something visually stranger than anything NASA's professional instruments had shown. Rather than a single, simple tail streaming away from the sun, the way textbook comets behave, 3I Atlas appeared to be growing multiple tails, including a faint secondary tail pointing in the wrong direction entirely, toward the sun rather than away from it. Jewett and his colleagues eventually explained the anomaly. The comet was ejecting unusually large dust particles, roughly 100 microns across, 100 times bigger than the fine dust typically assumed for comet tails. Because these particles were so much heavier, solar radiation pressure was barely affecting them, leaving them lingering near the sunward side of the nucleus instead of being swept immediately into a normal tail. It was an elegant explanation, but it only came after weeks of visual data that, to the untrained eye, looked exactly like the kind of anomaly that fuels wilder theories. And it was around this point that the loudest and most controversial voice in the story entered the picture. Avi Loeb, a Harvard astrophysicist known for previously suggesting that Oumuamua might have been an artificial object, began publishing a stream of papers and blog posts arguing that 3I Atlas displayed characteristics inconsistent with a natural comet. Its size, its trajectory, the timing of its brightening, the unusual chemistry, and suggested, publicly and repeatedly, that the possibility of artificial origin could not be ruled out. His claims spread far beyond the scientific community, picked up by headlines around the world promising evidence of alien technology entering our solar system. The response from the broader astronomical community was fast and largely unified. Nikki Fox, Associate Administrator of NASA's Science Mission Directorate, stood before reporters at a press briefing following the release of imagery from more than 20 instruments across NASA's fleet, and said plainly that the object posed no threat to Earth and showed nothing inconsistent with a natural comet's behavior. "The objects in our solar system will be just fine," she said, addressing not just this comet, but the broader anxiety the story had generated online. Jewett, whose Hubble data had done more than anyone's to characterize the object, was equally direct. The anti-tail, the outgassing, the non-gravitational drift. All of it, he said, was consistent with a comet nucleus of typical size, or smaller, sublimating in sunlight and blowing out dust particles. In other words, unusual, yes. Scientifically exciting, absolutely. But not evidence of anything built by another civilization. It would be easy to frame this as a fringe idea being swiftly dismissed, but the reality was messier and more human than that. Loeb is not an outsider to the field. He spent years chairing Harvard's astronomy department, and his underlying argument was never that 3I Atlas was definitely artificial, only that scientists should not rule out the possibility before the data justified doing so. His critics countered that extraordinary claims were being made in public, in real time, ahead of peer review, at a moment when millions of people were watching and forming their impressions of the object almost entirely from headlines rather than data. Dozens of astronomers who had never met each other in person found themselves coordinating informally online, cross-checking each new Loeb paper against their own instrument readings within hours of publication, racing to either confirm or rule out each new claim before it could calcify into public certainty. It became, in its own way, a live demonstration of how science is actually supposed to work. Messy, argumentative, occasionally testy, but ultimately accountable to the instruments, rather than to whoever spoke loudest first. That disagreement, one of the most publicly visible scientific arguments of the year, is precisely what makes the real story more interesting than the fictional one. Nobody needed to invent a secret NASA leak or a terrifying hidden photograph. The genuine tension between a minority voice pushing an extraordinary hypothesis and a majority of the field pushing back with hard data played out in full public view, article by article, telescope by telescope. Through November, the observation campaign only intensified. NASA's Europa Clipper mission, on its long cruise toward Jupiter's icy moon, turned its instruments toward the comet for 7 continuous hours from a distance of over 100 million miles, adding yet another data point to the growing catalog. The Lucy spacecraft, en route to study the Trojan asteroids near Jupiter, spotted the comet from 240 million miles away, a faint pixel of light that nonetheless represented one more confirmation of the object's position and behavior. NASA's Psyche mission recorded 4 separate observations across 8 hours. Heliophysics missions like STEREO and the joint ESA-NASA mission SOHO, built to study the sun rather than comets, spent weeks tracking 3I Atlas as it disappeared behind our star and re-emerged on the other side, giving astronomers rare continuous coverage through a period when ground telescopes were completely blind to it. Even the James Webb Space Telescope, one of the most oversubscribed and scientifically valuable instruments ever built, was pointed at the comet, using its near-infrared spectrograph to sample the chemical fingerprint of the gas and dust streaming off the nucleus, adding precision to the carbon dioxide and organic molecule detections first hinted at by Spherex. 12 separate NASA assets, by the agency's own count, had captured and processed imagery of the comet in the months following its discovery. An unprecedented solar system-wide observation campaign mounted for an object that would be gone permanently within a matter of months. By November 19th, at a press conference, many space journalists described as one of the most detailed comet briefings NASA had ever held, the agency released what it called the highest resolution images of the comet captured yet. New data from the Mars Reconnaissance Orbiter's HiRISE camera, timed around the comet's closest approach and perihelion passage. Boy, were they ready for this event, Fox told the room, describing how the observation campaign had pushed instruments built for entirely different purposes. Mars orbiters, Jupiter-bound probes, solar observatories, beyond their normal operating parameters, just to capture a passing visitor from another star. None of the images showed anything resembling a spacecraft, a structure, or a face staring back from the void. What they showed, again and again, from a dozen different angles and wavelengths, was a comet, an old, chemically rich, unusually large, unusually active comet, behaving in ways that were strange enough to justify genuine scientific excitement without needing to reach for extraordinary explanations. By January of this year, as the comet continued its outbound journey, NASA's exoplanet-hunting TS spacecraft captured a final extended sequence of images over several nights, adding to the timeline of its rotation and activity, even as it faded further from view. Somewhere out past the orbit of Jupiter now, and picking up speed as it falls back into the gravitational slingshot that will fling it out of the solar system entirely, 3I Atlas is leaving. It will never return. Whatever else it might have told us, about its age, about its true size, about the exact conditions under which it formed around a star we will likely never identify, some of those answers are leaving with it, encoded in data that may take scientists years to fully unpack, if the answers arrive at all. There is a reason this entire episode felt different from the two interstellar visitors before it, and it isn't just the size of the observation campaign, it's the timing of what comes next. A new observatory, the Vera C. Rubin facility high in the mountains of Chile, had only recently begun full operations when 3I Atlas was discovered, and its entire design purpose is to scan the whole visible sky over and over every few nights, cataloging anything that moves or changes. Astronomers who have studied its capabilities estimate that Rubin alone could detect several more interstellar objects every year once it reaches full operational stride. Not one every few years, as had been the case with survey telescopes of the previous generation, but a steady trickle of visitors from other stars, arriving often enough that within a decade, an object like 3I Atlas might no longer feel like a once-in-a-lifetime event at all. What happened this year, in other words, may not have been the exception. It may have been the first properly documented instance of something that has been happening, unnoticed, for as long as there have been comets and stars to send them our way, and the first sign of what is about to become almost routine. That thought carries its own kind of weight. Every comet native to our own solar system formed here, in the same disk of gas and dust that built the Earth, the Sun, and everything else we call home. They are, in a sense, family. Old, icy, distant family, but family nonetheless. 3I Atlas is not. It is a stranger, built from the raw material of a star system that may no longer even exist in the form it once had, given how many billions of years have passed since this object first formed. For a few months, that stranger was close enough to photograph, close enough to argue about over conference calls and press briefings, close enough that a rover exploring a crater on Mars could pause its own work just to look up and catch it passing by. And then, like the two before it, it kept going. Back out past Jupiter, back out past the edge of everything we can reasonably call our own, into the same dark it came from, carrying its unanswered questions with it. What lingers after the cameras stop and the press conferences end is not fear, but something closer to unease. The particular unease of realizing how little we actually know about what drifts through the space between stars, and how briefly we get to look at it before it disappears again. 2 confirmed interstellar visitors came and went before anyone on Earth was watching closely enough to understand them. This one we watched with everything we had. Hubble, Webb, a Mars rover, a Jupiter probe, solar observatories built for an entirely different star, and even with every instrument NASA could turn toward it, the deepest questions about 3I Atlas remain open. Its exact size is still unresolved. Its precise age is still a matter of ongoing calculation. The debate over what its behavior does and doesn't rule out is still, as of this telling, unfinished business between some of the most credentialed scientists in the world. Somewhere out there, moving faster than anything humanity has ever built, is a piece of another star system, older than our own sun, carrying inside it a chemical record of a world none of us will ever see. It came close enough to photograph, it came close enough to argue about, and now it is leaving, taking its answers with it back into the dark it came from.